In this video, we're going to do an example of finding the derivative of a function which is a function of x raised to a function of x. And in this example, it's find the derivative of y equals x to the 1 over x power. Now, unlike a lot of the functions that you're used to differentiating, we have a power of x, which is x, not a power, a function of x, sorry, raised to a function of x, 1 over x. So this is a function of x raised to some other function of x. In other words, you have something like f of x. Well, I don't want to call it f of x because that's, maybe I'll use f for the function that we're differentiating. So maybe g of x raised to h of x. And that's your f of x. And you're asked to find the derivative of f. Well, when you have something like this, you can't use the same rules that you had when you had a function of x raised to a power. So if you had something like f of x equals x squared, right? You can bring the 2 down. That's from the power rule. That's what it's called. Or if you had something like 2 to the x, the derivative is going to be 2 to the x times natural log of 2. So let's just recall that when you have this, the derivative is going to be 2x. When you have 2 to the x, the derivative is 2 to the x times the natural log of 2. When I have x to the x, or whatever, I mean, like 7x raised to the square root of x, something involving x raised to something involving x, I can't use the facts that I used for the other examples, because for the first example, that only happens when you have x raised to a number. So x to the 7th power, x to the, it doesn't even have to be an integer, it could be x to the pi power, x to the square root of 6 power. Then you can bring that constant down and then subtract 1 from the exponent. That's only when you have an exponent that's a number. We don't have that. And also, we can't use the formula for a to the x, where a is a positive number, because in this example, we don't have a positive number for the base. The base is x or 7x or some function of x. So when we have a g of x raised to the h of x, and neither the g nor the h are constants, we don't actually have any, we can't use those formulas. So we have to do something else. Turns out that what you can do is something called logarithmic differentiation. And what that is we're going to take the natural log of the function, and then we're going to differentiate that. So let's take the natural log. I'm just going to rewrite x to the 1x like that, x to the 1 over x. Then I'm going to take the natural log of both sides. Now, hopefully you remember your facts when you have the natural log. If you have a natural log of, say, a to the b power, that's the same as b times the natural log of a. Okay. So you may want to review that if you're unfamiliar. And we're going to apply that fact here, because I have the natural log of something raised to the power. So by the fact, now, I'm matching my a with x. So here I'm using, again, I'm going to do a little cloud. I'm matching a with x, and then I'm matching b with 1 over x. And if I just copy what the formula tells me that I have b, that's 1 over x, times the natural log of a, which is x. So I have that. So that's the natural log of y. Now I'm going to differentiate both sides with respect to x. And when I differentiate both sides with respect to x, what am I going to get on the left? Remember, y is a function of x. So I'm not going to get just 1 over y. I'm going to get 1 over y times the derivative of x, which is y prime. That's from the chain rule. And now, on the right, what do I have? What rule am I going to use to take the derivative on the right with respect to x? I am going to use the product rule, because I have a 1 over x times the natural log of x. Or you could either use the product rule, or you could do the quotient rule by writing it as ln of x all over x. This is natural log of. So sometimes there's parentheses, but sometimes there isn't. Okay, let's use the quotient rule since it seems a little easier. So we're going to have the bottom times the derivative of the top. What's the derivative of ln of x? It's 1 over x. And then minus the top, ln of x, times the derivative of the bottom. The derivative of x is 1. Normally I wouldn't even just write it if it's just times 1, but I'm going to write it out just so that you see it. And then this all divided by, what? X squared, right? From the quotient rule. So, on the left, I have 1 over y times y prime. That's y prime over y. And then on the right, let's simplify. I have x times 1 over x, that's 1. And then minus natural log of x times 1 is the natural log of x. And then on the bottom, I have x squared again. And now do you see what I can do to solve for y prime? I can multiply both sides by y. So I multiply both sides by y, I get y prime is equal to y times 1 minus ln of x over x squared. Now don't leave it like that, because your answer should be all in terms of x. Can we get everything in terms of x? Yes, because in the problem you're told what y is equal to. It's x to the 1 over x power. So the answer is, okay, we're basically done, because it's just x to the 1 over x power times that, 1 minus ln of x over x squared, and that's the answer. That's y prime. So that is logarithmic differentiation. Let's write down the key steps. And this is something that you should be thinking of whenever you have a function which is a function of x raised to another function of x, and you're trying to find the derivative. So whenever you have a g of x raised to h of x, and you want to find the derivative, use logarithmic differentiation. And what is logarithmic differentiation? Let's summarize the steps. So the first step is to take the natural log of both sides. Then you bring the exponent down. So use that property of the natural logs, which is up here. Maybe I'll use green because it's a little brighter. Like that. You rewrite it like this. So now you have ln of y equals, something. And then you take the derivative of both sides with respect to x. So you do the derivative of x, the derivative with respect to x of both sides. And then you're going to get y prime over y on the left. You're always going to get that. Whenever you have natural log of y, the derivative is y prime over y, okay? Because of the chain rule, because you have a 1 over y times the derivative of y, so it's y prime over y. And then you're going to get something on the right. It kind of depends on what your function is. So you're going to get y prime over y equals something involving x, and then the last step is to multiply both sides by y. And then you're going to get y times something, and then you just substitute your y back in so that you get everything. So substitute the y back in. Substitute y back in so that you get something that's just involving x. So let's think about the kind of big picture kind of thing. So you have some function f of x, which is g of x raised to the h of x power, and you want to find f prime of x. So step 1 is you take the natural log of both sides, like that. Then you bring the h of x down from the properties of natural logs, like this. So that's your ln of f of x. Then you take the derivative of both sides. So you're going to get f prime of x over f of x. And then on the right, I mean, we could even just write down the general formula from the product rule. You're going to get h of x, the first function times the derivative of the second. The derivative of natural log of g over x is g prime over g. So g prime of x, and then this all over g of x. Then plus the natural log of g of x times h prime of x. And so now you multiply both sides by f of x, so you get f prime of x equals f of x times h of x g prime of x over g of x plus the natural log of g of x times h prime of x. I wouldn't memorize this formula. I don't think that's a good idea. But I'm just trying to explain the general outline. You can always do this whenever you have a function of x raised to the power of a function of x. This is the steps to logarithmic differentiation. And as you can see, it's always going to work. You know, as long as your function is positive. I mean, that's something I kind of swept under the rug. But if your function is negative, then of course you can't take the natural log of something that's negative. So throughout this whole process, we're assuming that these functions that you're differentiating are positive. So maybe I should have said that at the beginning. So here we're assuming that x is positive, so that the inside and the base and the exponent are both positive. That's something that should be stated, strictly speaking, so that we can actually take the derivative. Sometimes they don't say that just because it's clear that you're supposed to use logarithmic differentiation. And they also don't want you to worry about these kinds of things. Okay? Perfect. So that's what you do if you want to take the derivative of a function raised to another function of x. Use logarithmic differentiation, you do these steps, and then you're going to get the answer.